Okay, so we're still talking about rational exponents, and we've done problems like cube roots where it would equal 1 over 3. But a rational exponent doesn't always have to be in the form of 1 over n. This doesn't always have to be a 1, right? It could be another number. I mean, you could have a fraction like 3 over 2, right? And so how would we handle that? Well, we could use the properties of exponents to evaluate or simplify expressions involving these type of rational exponents, okay? So, rational exponents, let's let 1 to the nth begin with the nth root of a, and let m be a positive integer. I'm going to show you what that looks like with algebra, then we'll substitute some numbers in. So instead of a 1 here, we'll put an m where the 1 was before. So it's like a to the m over n, which would equal 1 over n to the mth power, which of course we talked about which would look like this. If the m is already kind of on the outside, we could just convert this to its radical form as we were doing already. All right, if that was confusing, if you're not, let's substitute these numbers in and see what we're talking about. So with numbers, if we have 22nd to the 2/3 root, you could take out the 2 and put it on the outside of the parentheses. And if you think about it, it makes sense, because if we were going forward, for instance, if we're going this way, we would multiply, right? Let me just write it out real quick so you can see what I'm talking about. We'd multiply the exponent by the exponent, right? But 1/3 times 2 would be 2/3, right? So all we did was do that in reverse. We took the 2/3 and we took the 2 out. But then we're left with just 1/3. Well, we already learned that 1/3 would be the cube root. So the 2 is just on the outside. That's the m. So whatever's here on the numerator ends up being on the outside. Whatever's the denominator ends up being at the index, okay? Hope that makes sense. Let's go ahead and do some examples. Kind of look at what we're talking about. So 2 questions. It says evaluate 16 to the 3/4 and 27 to the 4/3 power. Okay, so let's do the first one, 16 to the 3/4. Now just as a reminder, that's also the same thing then as 16 to the 1/4, but to the 3rd power. That's the rational exponents, right? And then, so first thing we're going to do, and these are always the order we do it in, is we're going to evaluate the nth root first, and then we'll evaluate the power. So let's take the root out first, and then we'll do the power. So the root first. What is 16? What is 1/4 of 16? Well, if we were to do that first, it'd be 2 times 2 times 2 times 2 would be 16. So we could take the 2 out, and that would get rid of the 16 to 1/4, but we still have the power. So what is 2 to the 3rd power? That would be 8. So the answer to this is 8. Notice we just evaluated the root first. We did this part first. Then when we had the answer of 2, we did 2 to the 3rd power, which is 8. So these 2 steps will get us through all of these type of problems. So let's look at the next one here. Cover the answer there. And we're going to do these same 2 steps, right? So we have 27 to the 4/3, right? Another way you could write that is 27 to the 1/3 to the 4th power. Basically, the m is just going on the outside. Okay, so what is 1/3 of 27? I mean, what times what times what would be 27, right? It would be 3 times 3 times 3. I would write the factors out. And if you were to take 1/3 of those 3's, the answer would be 3. So that's the root. It'd be 3. But then is 3 to what power? To the 4th. But what is 3 to the 4th power? 3 to the 4th power would be 3 times 3 times 3 times 3 are 81. So the answer to this is 81. Okay, hopefully that was helpful. It is now your turn to try it. 6.2b. Go ahead and give these a shot. Of course, it's also in your textbook on page 301, at the bottom of the page.